This is a rare event, and I think it's important. I think it's important to appreciate how rare it is. How many times can you think of when a major new field guide of a major resource such as Mount Tam has come out in Marin County? This is the kind of thing that happens several times, perhaps in a lifetime, or certainly is in your adult lifetime. And it's a very, very special occasion to have a new field guide, the Plants of Mount Tamalpais, a field guide, be published. And we have the honor of having the author discuss it with him. But not only are you going to hear about the field guide today, we're also going to give you information about how to get a 30% discount on the purchase of the field guide through the Marin CNPS website. That popped out again. I'm going to get rid of that, and I'm going to bring up another share screen, which, can you see that?
No.
Sorry, that didn't work. There we go. This is the basic information you will need to get the discount on the site, and I'll put this in the chat as well, so you can have it. The code that you put in the site is Tamalpais, all in full caps. This will be up for a week through December 18th, and you go to the shop. You don't really have to have this. If you go onto our website, you'll see there's a tab up at the top and says shop, and you can go directly into that, and you will see the thumbnail of the book, and you can go from there. So as I say, I will put that into the chat during the presentation, and you can use that. Now I'd like to introduce Robert Steers. Robert, the author of the new field guide, his botanical journey started early. He volunteered to remove invasive plants at a local conservancy in Southern California in high school. And after majoring in ecology and systematic biology, how prescient that was. I mean, what is a field guide but systematic biology? At Cal Poly San Luis Obispo, and he received a Ph.D. in plant ecology from UC Riverside. And since 2000, he's worked as a botanist and ecologist for a variety of agencies and academic institutions and consulting firms. And he's not a narrow gauge botanist. He has botanized all over California, from the mountains of the north to the deserts of the south, and resided in Marin County for over a decade. For several years, he was the regional vegetational ecologist for the San Francisco Bay Area network of national parks. This is a group, as I understand it, that is over individual national parks. And in that role, he managed the plant monitoring programs in GGNRA, in Muir Woods, in Point Reyes, and other units. And he now does contract work for land management agencies in the county, mostly related to rare plants. And he has a world outside of plants that he's developed, which is a manager in hardware and software products, in addition to his interest in plants. So at this point, it's great pleasure to turn the program over to you, Robert.
Yeah, thanks for the nice introduction. Really appreciate it. Thanks everyone for joining. Hope we can have a good discussion about Mount Tam, probably one of our favorite places in the world. Every time I go on vacation, I come back. I drive into town, across the Richmond Bridge, or or fly in and you see Mount Tam, and it fills your heart up a little bit, right? It's a really awesome spot. So thanks a lot for joining, and hopefully you'll get something out of the presentation, and you'll enjoy the book. And I'm also very grateful that the chapter can help with that discount. That's so cool. So thank you very much. I'm gonna start sharing my screen and put my monitor into presentation mode. Hopefully, like I said, I don't. Here we go. Share screen. Don't use Zoom too often, so just bear with me. All right, so hopefully people can see my screen, and we'll go into presentation mode. All right, and there might be a little bit of a bar up at the top, but yeah, I don't know if you can see the bar or the panel on the side. Maybe I can get rid of that. Move that over here.
No, we can't see it.
Okay, so there's things that I can see that you can't. Thank you. Okay, great. So yeah, this is the presentation on the field guide to the plants of Mount Tam. So I'm going to start off talking about my background a little bit, but not too much, since that already got covered. I want to also, in the front, do the acknowledgements. Lots of people to thank. Then we'll go through a kind of a timeline of how the field guide got developed from the beginning to current. And then we'll actually get into the sections of the field guide. So a lot of this presentation will cover natural history aspects of Mount Tam. And then the other big part of this presentation will cover the habitats of Mount Tam. So I want to emphasize a lot in those two areas because they provide the context, for all the species that grow on the mountain, and the field guide itself, with all the species that it covers, which is a little over 600, is kind of, it's reference information. It's there for you all to access and check out. But I like the context a lot because it adds a whole nother dimension to understanding the species, why things grow where they grow. So right now we're looking at a view of Mount Tam from the south. This is from Diaz Ridge, and right in the middle is Muir Woods. We've got Redwood Creek coming out of it. And then we've got the ridge line in the background with East Peak on the right side and Pantole on the left, with Rock Springs just kind of right over the ridge. It's view a lot of people here are familiar with. On the backside, this is a picture taken from the top of East Peak. You can see Bolinas Ridge. You've got Pine Mountain. You've got Barnaby Mountain, which is out by Samuel P. Taylor, like a little bit of San Geronimo Ridge poking out. We're just south of Sir Francis Drake. We got White Hill, we got Pilot Knob, which is pretty noticeable. Just out of view is Bald Hill, right? Just right above San Anselmo. We've got one of the reservoirs showing. This also could be your view of Mount Tam. This is a picture of Bolinas Ridge. So you could be in West Marin, and you would see this kind of view. It's Mount Tam proper is over to your right. But this is kind of the view from the west side. So you might be from West Marin, and you're more used to this view of Marin. You might be from the east side, and you're more used to this view, right? This is one of my favorite areas to walk. I live kind of close to here. It's the Long Court of Madera Creek. Some of you reside south of Marin in San Francisco, Daly City, or other parts of the Bay Area. So most of you can see Mount Tam from some spot where you live. If you're from the Bay Area, it's one of the major mountains in the area. It's very noticeable. This is a grainy photo I took from the Livermore, museum above UC Berkeley. Took my kids here when they were younger. So this is the view of Mount Tam for some of you folks that are in the East Bay. This is a picture of Mount Tam from Orange Day. You all remember Orange Day? during COVID, and we had those really intense wildfires. So sometimes we see Mount Tam, it's like this. And last year, we got a great dusting of snow. So every once in a while, we'll see Mount Tam with snow. So I think we all know Mount Tam, or have heard about it if you're not from the region. It's a very special place. It's got multiple faces, and I'm just really happy I got the chance to spend so much time on the mountain and put together a field guide. So yeah, section one, we're gonna just cover my background really quick and then cover the acknowledgements. This is a map. It's California kind of twisted on the side. I won't go through all the details, but I grew up down in Southern California. I went to college at Cal Poly and did my PhD out at UC Riverside. But along the way, I had a chance to work for a lot of different organizations in California and botanized, up in Modoc and in the Sierras a little bit. Did a good amount of work in the Southern Coast Ranges and a lot of work down in Southern California on the coastal side and in the desert. And since around 2009, I've been in the Bay Area, and I've been working in Marin and some other locales regionally. So before I was in Marin County and part of my undergrad and graduate work, I did try to publish papers as an academic. That was, an important aspect of the job. So some of my early work was related to desert wildflowers and fire, and the interplay between fire and invasive species, and also how nitrogen deposition and air pollution affect that balance. I've also done some work on highly degraded coastal scrub that's just been burned, repeatedly to the point where it type converts, and you get some really interesting changes to those communities where if you could see all these holes, this is pocket gophers just come into the area and take over once all those woody roots are gone, just totally transform, these hillsides completely. As an undergrad, I did work on property at Cal Poly doing vegetation mapping, and another really fun project I worked on in grad school was looking at how desert chaparral and the transition from cismontane to the desert floristic province, like what happens to that vegetation as you go from the wet side to the east side? How does diversity change along that gradient? What kind of fire adaptation strategies are there? So yeah, this is just a sampling of some of my previous work. I've got a background in plant ecology, so that comes out, I think, in the field guide a bit. In Marin County, once I started working for the Park Service, one of the big projects I did was helping to develop the plant community monitoring protocol for Golden Gate, Point Reyes, Muir Woods, Pinnacles, and Muir Historic Site out in the East Bay. So that was a really big effort. Through that project, I was able to do some pilot studies. So I did a study out in the Marin headlands on the grasslands out there, and I was able to do some investigations of the old growth forest in Muir Woods. So just really fun projects, just trying to describe what we've got here in Marin and make that accessible as reports. Also was able to do some actual research projects too, looking at the effects of invasive pine trees on coastal scrub in the Marin headlands, and then some work with NASA looking at vegetation change since 1985 and trying to correlate changes in vegetation to landscape scale patterns like water availability. Yeah, so just to make sure I cover the folks that have helped me along the way, my time at Cal Poly was really awesome, and I had some great mentors there, like David Keel, wrote the Key to Asteraceae and Jeps Emanuel, V.L. Holland, and Mike. These folks, inspired me to pursue a botanical journey. While I was an undergrad, I was able to get jobs in the summer as a seasonal botanist for the Forest Service in Colorado State out at Fort Hunter Liggett. And those people that were my managers there and my coworkers were really helpful in my botanical education. I worked at Cal, had some great interactions and help from grad students mainly there. So shout out to those folks. At UC Riverside, my advisor, my committee, Andrew Sanders, who worked in the herbarium there, just an amazing botanist, and just learned tons and tons from Andy and my colleagues at UC Riverside. So thanks there. I worked at LSA. I didn't overlap with Eva. She retired right when I joined, but she did leave the herbarium, and we tried to take care of that. But people at LSA, you know, like Clint, who's been involved in the chapter, you know, just really great people that I've learned a lot. And then in Marin, the Park Service, and then more recently with Panorama, where I do some contracting work. There's just a ton of people in Marin that I've learned from. Some of these people have helped to review the book. So I'm just incredibly grateful for all the people I've worked with, and they're, you know, part of my botanical journey, and I'm sure everybody on the call has, you know, their list. So thanks for listening to that. I just really thankful for these people, and glad I had the opportunity here. In terms of the field guide, there's, you know, 4 people locally who helped to review it. David Greenberger, who I think most people know very well, and he's been on the CNPS board here in Marin. He was one of the reviewers. Doreen Smith, who's also, you know, a legend in the book. Eric Rubel, he was a former colleague of mine at the Park Service. He was able to review, and so is Sherry Adams, who's the current vegetation ecologist for NMWD. So really big thanks to the 4 reviewers who took time to look at the manuscript and offer suggestions and make point out areas that needed help. So thanks to all of those folks. And then lastly, I want to thank, or maybe not lastly, but almost lastly, I want to thank, you know, the folks at Backcountry Press. This is Michael and Allison. So they're just a husband-wife team, and they put out tons of really great books. Most of it's focused in Northern California, but, you know, they've got a book on the desert plants, and they're expanding, I guess, with this book down into the Bay Area. But they've also done, you know, the field guide to manzanitas that Tom Parker and Mike Vassy co-wrote with Michael. So just big thanks to Backcountry Press for taking on this project and believing in it. Lastly, I want to thank my family. Pretty much raised my kids on the weekends up on Mount Tam when I was taking photographs for the book. So I've got like thousands and thousands of pictures of my kids up on Mount Tam as I've, you know, taken them on hikes to go photograph plants and spend time out here. So it's kind of us. It's kind of more for them, just to, you know, see them growing up through the years as we've been on the mountain. Now they're pretty big. They're in junior high. Want to give a shout out to my wife's cousin Jen. She's a local photographer. Took a nice photo here. But yeah, my kids have been a big part of this, and my gracious wife for, you know, letting me spend so much time on it. All right, so thanks a lot. And this part of the presentation will go over the field guide. So we'll start with kind of the history of the field guide, how it started and how it ended.
Why are you doing this?
Someone might need to go on mute unless you have a question. Okay, so the field guide. So I started working at the Park Service in 2010, and one of the things I noticed right away was that there wasn't a field guide to Muir Woods, and to me that was really surprising because there's really hundreds of thousands of people who visit that park, and it's basically a park for plants, right? People go there to actually look at plants, look at old growth redwood forests. So almost as soon as I started working at the Park Service, I thought, we just need a field guide to Muir Woods, like it's going to fulfill an important gap. As I started to work on that, pretty much started that after my first year, I quickly realized, and this was before the parking reservation system was in place, that people would come down in Muir Woods, they wouldn't find a parking spot, and then they'd just end up at Muir Beach, or they would, drive along Highway 1 and try to find a place to hike, or they'd come up on the top of the ridge and visit Rock Springs or go to East Peak. And so this whole area in general just seemed to be like really highly visited. And it's such an amazing area. Like I couldn't resist not expanding the scope of the book. So around 2013, I started working on, this area that was outlined, right? And yeah, I wanted to, make sure that Muir Woods, Muir Beach, Bootjack, Pantoll, Rock Springs, East Peak were really well represented. So the priorities for what to include in the book were based on finding the most commonly encountered species, trying to identify, iconic or well-known species, and then anything that was, really eye-catching. So plants that, people either knew a lot about, maybe they're not common, but if you saw it, you knew it, or you knew you should know it, and then just, the very common species. So in 2011, I had about 130 species that I was working on. When I expanded to 2013 to the broader area, I already had a lot of the photographs, but I had a target list of around 550 species, which is pretty big, right? So when I was first pitching the book, it was the plants of Muir Woods and surrounding Mount Tam. It wasn't, a field guide to Mount Tam. I really wanted to focus on Muir Woods and basically the Redwood Creek watershed in that area that was shown. Around that same time, the One Tam project was kicking off, right? And Sharon Farrell was leading the charge there. And I approached Sharon about the book, or somehow we started talking about it, and the Golden Gate Parks Conservancy took a big interest, and so especially Sharon. And so Sharon talked me into expanding the scope of the book from this area with 550 species to all of One Tam. And so I thought, actually, after thinking about that increase, expanding for the whole One Tam, made sense. It aligned with One Tam, and it seemed like the right call. So after talking with Sharon, that was the plan. So roughly we started with Muir Woods, we expanded to Redwood Creek watershed, got about 75% of the book done around 2015, right? Then I started to pitch it, as I said. Golden Gate Parks Conservancy picked it up as long as it was part of One Tam, right? And then I worked on the book, right? And for these several years after GGNPC picked it up, COVID hit, in March of 2020. I completed the book, or what I thought was the book. GGNPC had an update because of COVID and the changes in priorities. They weren't able to actually publish it, but they did stay on to sponsor it. So huge thanks to Golden Gate National Parks Conservancy. So right after that update and their priorities, I took it to Backcountry Press, and with GGNPC sponsorship, and they picked it up. Then we started reviewing the book, worked on revisions for quite a while, worked on a lot of reformatting, rewriting, and then here we are today, and the book has been published. So pretty long journey. Of course, if I could have done this during the day and not just on the nights and weekends, it would have gone a lot faster. Just a ton of patience too from Sharon, in the early years, just waiting for me to hurry up and get done. So yeah, there were some periods of time, like months, where I couldn't even touch it just because work was so busy or there was other obligations. But yeah, this is basically how it started and how it ended. Okay, so this field guide right here, it is the topic, but I want to discuss it in the context of some of these other resources. So there's a lot of resources available to botanists in Marin County. It's probably one of the most highly botanized counties in California. And there's just a ton of awesome resources for Marin County. So, I see this as one tool in a pretty big tool chest for botanists. There's a lot of great taxonomic resources. So the Jepson eFlora is, kind of the source of truth for plant taxonomy in the state and, this county. We've got the Marin Flora, which also, is a insanely valuable publication. And my copy's in the back shelf. You can't see it because I've got a background screen, but my copy's pretty much obliterated. I've just, devoured it over the years. I need to get a new copy. But, there's other taxonomic resources that botanists can take advantage of. Keys are really important. There've been a lot of revisions to taxonomy over the years, and so the great thing about Jepson eFlora is they publish their updates online and keep everything up to date there. Then there's all these databases and tools like CalFlora. The Jepson Herbarium also has some great online resources, CalPhotos, the Consortium of Herbariums. There's a great website to the sedges of Marin County. Andrea, the former vegetation ecologist, and Michelle O'Haron put together an MMWD rare plant inventory you can find online. iNaturalist is just absolutely amazing with tons and tons of information there. We've got plantid.net, which covers a huge area beyond Marin. But if you're in Marin, it's a really great resource because a lot of the content is developed by folks I think from the county. Definitely the Bruce who put it together lives here locally. So that's another great resource. The Marin chapter has tons of great resources on their website, and so does CNPS and a lot of others. In terms of field guides, there haven't been a lot. There was a field guide to Point Reyes National Seashore in 1970, and then more recently we've got the checklist, right? And then also the wildflower book. So now we've got some pretty up-to-date resources, and so Point Reyes is in great shape, and those are also helpful for other places beyond Point Reyes too. For Muir Woods, like I said, when I got to the park, there wasn't anything there. There was a field guide in 1963 called Flowers and Ferns of Muir Woods, and I've got a copy, and it's great, but it's pretty out to date. I just found out a couple days ago that there's a field guide to Muir Woods now that just got finished in 2023. So that's another great resource. Hopefully that people can check it out. I don't have a copy, but I'm definitely going to get one. And then there's the field guide to San Bruno Mountain. This also just got finished this year. San Bruno Mountains, south of San Francisco. David Nelson, if you don't know him, he's a hand doctor or hand surgeon, and he's got an office in Greenbrae, but he lives down in the city. He actually did work on one of my kids and found out he was working on this field guide before it was done. Really amazing doctor, like helped my kid's hand heal completely. It was totally shattered. But there's a lot of overlap with San Bruno and Mount Tam. So here's another great resource. And then we just got, this field guide done. So between the taxonomic, the databases, and the field reference guides, we've got you covered in Marin. And of course, no resource is perfect, right? But there's a lot of tools available, and there's also a great community here. There's always been a great botanical community here. So lots of knowledge sharing and people to lean on. So taking a look at this field guide, there's about 618 or so species that are specifically covered, and then there's reference to a lot more species. So with any kind of resource, it should work great for the area that it's been written for, right? So it better work good on Mount Tam. It's a geographic scope, right? It should, though, work pretty good for a lot of the Bay Area and North Bay. There's a lot of the common plants are, throughout this whole area, especially on the coastal side of the East Bay Hills. So it should work decent, right? But you should proceed with caution. I don't want to give people a false sense that a field guide to Mount Tam is going to cover them, in southern Mendocino County, right? Because the amazing thing about California is it's just got a huge amount of diversity, right? But yeah, for people who want to learn more about plants in their area, it should work decent, for places outside of Mount Tam. Going beyond that, proceed with, major caution, right? It's going to lack some important plant species, but you should be able to glean, some useful information from this book, I think, kind of in this area in pink. So yeah, right. So that's about the field guide and how it came to be, and the geographic scope. A lot of the field guide is focused on the species, but I'm going to spend a lot of this presentation just talking about the natural history of Mount Tam, as I discussed previously, to provide that kind of context. So there's a lot of factors that influence, why certain species grow where they grow. And this isn't a comprehensive list. I'm just trying to provide some information on some of the most common factors that affect where species grow. So climate is hugely important, the regional climate, and then the Bay Area is famous for having microclimates. So kind of the climates at a local scale actually are really important on Mount Tam, as they are throughout a lot of California. The geology and soils is a critically important area for determining plant species, especially when you're talking about different parent materials like serpentinite and its properties. But we'll get into the soils a little bit later in the presentation. Topography has a major effect, right? It influences the solar radiation, north versus south facing slopes, your exposure to fog. Mount Tam is tall enough to have some orographic precipitation influence, right? So increased precipitation with elevation. We also have disturbance history that plays an important role in why plants occur where they occur, right? The most obvious, of course, are roadsides and trails, and you get weeds that grow along those corridors, right? But traditionally, I guess you could say, fire is kind of the classic disturbance event that influences species and the trajectories of plant change. And so we'll talk a little bit about fire, and then also proximity to the coast is important when you've got the big Pacific Ocean right there, and all the wave activity and the aerosols that influence plants. So yeah, I know a lot of folks here on the call are some people are very well versed in all these topics. Some folks may be just getting their feet wet with botany and ecology. So thanks for your patience for the folks that are already really familiar with these concepts, but we'll walk through them for the sake of completeness. So yeah, first up, is the climate of the area. So these areas in pink are those areas in the world that have a Mediterranean-like climate, right? So we've got California, we've got Chile, we've got the Mediterranean region, South Africa, and portions of Southwest Australia and South Central Australia. And what characterizes, the Mediterranean climate is cool, wet winters. So here's temperature, right? And this is San Francisco, and this is LA, but cool temperatures in the winter with rainfall. And then in the summer, very, very little rainfall, if any, and warmer temperatures. So these graphs are inverted for, the Southern hemisphere, where you've got the green bars in the middle, and instead of a hill of red, you've got a valley, right? But it's the exact same weather pattern. For San Francisco and LA, this is what it looks like. And, you can see that just going down the coast, you've got quite a drop in precipitation. All right, another, classic variable for our climate in California, at least, is the interannual variability in precipitation. So last year we had a record, breaking rainfall year. It was just huge amounts of rainfall. This is a data set I pulled together when I worked at the Park Service with some weather stations from your woods, Petaluma and San Francisco. And you can just see like that the precipitation here in inches is just ping-ponging quite dramatically throughout the years. So we do get a very high amount of interannual variability. This becomes really probably most important for annual species that complete their life cycle, in less than a year. They germinate after the fall rains, and they die by summer, at least the majority of species. So while Mount Tam being close to the coast and having mild weather overall, you don't see maybe as dramatic alterations in the displays between years. You do notice it if you start to pay attention. So yeah, we've got a lot of interannual variability in precipitation. And next we're going to take a look at geology. So the geology of Mount Tam is varied, right, and complex. Interestingly and fortunately, from a botanical standpoint, we've got large areas of serpentine, these areas in purple. These are ultramafic areas of parent material. And serpentine, if you're not aware, is a very unusual soil type with a mixture or some interesting chemical properties that we'll talk about that select for plants that are specifically adapted to it. And so you get, kind of a boost in your species diversity in areas that have serpentine because of the specialization that it promotes. The of Mount Tam is kind of like marine sediment rocks and mixtures of rocks that have metamorphosed, right? Metamorphic rocks that have undergone, different changes over millions and millions of years. The Franciscan shale complex is basically what we get throughout most of Marin. And it's mostly marine sedimentary rocks and variations on that. So there's other soil types in Marin County, like on the west side of the San Andreas Fault in Point Reyes. You can get granites, right? And you get the Bishop pine forests out here, right? But geology and the parent materials are a very important part of determining why certain plants are found where they're found. And here's an example of a serpentine outcrop up at Rose. And serpentine soils are characterized by high magnesium and low calcium. So this creates a relatively less than ideal situation for plants. And so species that have been part of the mix here in California for thousands and thousands of years have evolved, and we've actually have a lot of speciation that's a result of these soil conditions. And you can see it has a pretty big effect in this area, right? There's a noticeable difference between the rock outcrop and the areas off of it, right? Where the soils could have some serpentine characteristics, but not nearly as extreme as that found in that exposure. Again, besides parent material, the soils and how they change on the landscape have a huge effect on the plant species. This is an example off of serpentine. You're going from relatively deep soils to shallow soils, and so you start to see a transition in plant species, and you get like a little kind of pseudo patch of chaparral here that's associated with different soil conditions. So besides geology, there's just an amazing amount of soil diversity that results from all these different types of rocks that break down over time. Their position on hillsides, if they fall down into valleys alluvially and create kind of deposits at the bottom, or if they're more exposed to precipitation on maybe one side of the hill, or to solarcation and the associated plant growth that can be associated with that, you're going to have differences over time in how the rocks weather and what kind of soil properties you get. So there's just a multitude of soil types that can be found on Mount Tam, and they'll influence the plant species that you can find in any one area. So yeah, if we look across the landscape of Mount Tam, you can see areas with different parent materials and different soil types, and you get a really interesting kind of smorgasbord of different vegetation types and species. And this is common throughout California. I think I have I'm skipping too far ahead, but I've got a vegetation map, and it's results in what we call a vegetation mosaics, where you've got a lot of different vegetation types that are sprinkled across the land, almost like a Pollock painting, right? All right, so topography is another major aspect of Mount Tam that has a major influence on plants. So typically, as storms move off the coast, if they hit a large mountain, as the clouds move over that feature, they push up in elevation. They get pushed up in elevation, and they get into colder air, and then they start losing more moisture out of the clouds, right? So you get an effect called orographic precipitation, which means that you get increased precipitation as you move up the windward side of a mountain. Mount Tam isn't so high and dramatic that it results in a major rain shadow, right? With dry air and a desert on the other side. So we're not dealing with like the Sierra Nevada here, which has like 10,000 foot mountain ridge that really sucks the moisture out of all the clouds. But you do have an effect of the topography on rainfall. So that's an aspect of Mount Tam. Right, so just to illustrate that, I found 3 weather stations more recently, one in Stinson Beach, one on the top of Mount Tam, and one in San Anselmo, and took a look at average monthly precipitation during a 3-year period, right? And Middle Peak here in green, they're color coded. So up at the top of the mountain, you definitely get more precipitation over the 3-year period. You're going from like an average of 20 inches of rain in January to like 10 and 8, in the winter months on top of Mount Tam on Middle Peak. Out of Stinson Beach, we had the lowest average precipitation, which was just common along like the immediate coast. That's what we also see out at Point Reyes. Actual precipitation is relatively low compared to Mount Tam, even though it's such a wet area and lush up there. Right, and San Anselmo is kind of right in the middle, so we do get a lot of storms that pass around the mountaintop, or the orographic effects, I think, kind of tumble off the mountain in some cases, right? And you do get quite a bit of precipitation out in San Anselmo, more so than at Stinson Beach, for example. Temperature-wise, we also see a big difference between the top of the mountain and Stinson. I don't think it would be a surprise that Stinson Beach stays pretty constant throughout the year, right? It does get a little warmer in the summer months, but you don't see as much seasonality because it's buffered by the ocean. The ocean's like a refrigerator that kind of keeps things constant, and it gets a lot of fog exposure. So Stinson Beach stays fairly constant from a temperature, relatively constant from a temperature perspective for both the average high and average low. Middle Peak, has the strongest seasonality, and it's actually really, pleasant, warm weather in the summer months. A lot of times on those foggy days, you might think it's not that nice up at the top, but you're outside of the fog, and it's pretty awesome. And then San Anselmo is fairly similar to Middle Peak. It's a little bit less seasonal, but we're not talking anything major here, right? It's just mainly the low temps don't get quite as high as Middle Peak in the summer months, and could be due to cold air drainage or the layer that kind of traps fog or cooling aspects closer to the surface. I'm not exactly sure, but you don't get as much of an increase in your summer precipitation. All right, and then as most people know, there's big differences between north and south facing slopes. So on north facing slopes, you can get forests, like this is an example near Phoenix Lake. On the south facing side, you can get sagebrush and species that you'd find all the way down in Southern California. Some of this is also because this hillside gets treated, right? So I don't want to dismiss that. If you're familiar with Crown Fire Road, you know what I'm talking about. But just for the sake of illustrating this point, north versus south facing slopes can have really dramatic differences in species composition. So I'm just using this picture for those purposes. All right, and then here's this like fine scale vegetation map, and you can see the mosaic patterns that I was talking about earlier. So both parent type and soil type and topography, they all like influence where certain species are found. And so with a diversity of soils and with the diversity of topography, you end up with this kind of situation where you've got pretty different vegetation types that can occur right next to each other. And it can seem random, right? It can seem like totally wild, but if you do know what to clue in on, it's very predictable. Like it's really a function of the substrate and the aspect and some other additional variables. So another awesome resource that's come out recently has been this fine scale vegetation map. Definitely encourage people to take a look at it. This was led by Golden Gate National Park Conservancy, TAM, and they worked with a lot of the agencies locally to develop this. And it's just a super cool resource that we have, and very helpful for learning more about Mount Tam and the whole county. All right, so I do want to get back to topography. This is just a super important aspect of Mount Tam. It's one of the highest peaks in the Bay Area. It's visible from pretty far away, and it's got this noticeable kind of check mark. So we've got Bolinas Ridge here, the east side of the San Andreas Fault, and then we've got the ridge kind of takes a 90-degree turn and goes towards Larkspur and Ross and whatnot, where you've got the highest peaks. So this is I think one of the most important features of Mount Tam in terms of determining kind of species. You've got this check mark, and when it comes to fog and the influence of fog, it really comes into play. Spent a lot of time looking at fog maps, aerial satellite imagery of fog, and you can see kind of that check mark that shows up. That Bolinas Ridge and the east to west peaks of Mount Tam really effectively block a lot of fog and create a pretty different climate on the leeward side of the ridges compared to the windward side, right? And if you take it, and if you're paying attention to the plants, you can really see the difference. There's a lot of species on this coastal side that just can't make it, just aren't found on the leeward side, right? And so fog itself is just super cool process to understand. In the summer months, we get high pressure systems over the Pacific. They spin clockwise, so they really drive a lot of wind, especially like if you're up in the town of Mendocino and that area, you really can experience it. Just tons of north to south pushing wind, right? And that causes upwelling, and our water gets actually really cold in the summer. It can get really cold in the summer, and when you have that your warm summer air going over this cold ocean, you get condensation, and that's the result of fog. And so we have constant fog here, as most of you are aware, throughout the spring through early fall, and sometimes it's low fog and sometimes it's high fog, right? And the height of the fog is just determined by the high pressure system over the region, and if it's really strong high pressure or not. If it's really light, you'll get like really high fog, and the fog will be higher than Mount Tam. A lot of times it's lower. So yeah, here's an example from, I think, Middle Peak, just showing, this beautiful blanket of fog going over the panoramic ridge, towards Mill Valley and Sausalito and the headlands. Here's, another example kind of on the opposite side of the spectrum, where we've got like a big fog bank that's, making its way all the way to like about 2,500 feet, the height of East Peak. So yeah, so just to understand fog more, I found an old paper that some weather folks put together in 1945 from San Francisco Airport, and they mapped fog and the distance of the fog from the airport and the height of the fog through over a four-year period. So I replotted their data into a graph just to kind of understand the average ceiling height that they reported of the fog, right? So from the southwest, I shouldn't have said, yeah, from the southwest, based off of 4 events, they had an average height of 2,000 feet. That's how you read this graph. Like from the west-southwest direction, if that's the way the wind was blowing, that was a more situation. They had 39 events. The average height was 1,300 feet, and so on. So you definitely get a peak like here, mainly from the west, which makes sense because that's how the fog rolls in, where you got a lot of fog events coming from the west. You've got barely any fog events coming from the east, because in those foggy months we don't really get that offshore pattern that we're used to in the fall, right? So most of the fog is occurring from the west and at those heights. So that's about 93% of the fog at San Francisco. And there's been studies that have shown how fog is changing over time, and how climate change could affect fog. But I think this data is still pretty useful to us and helpful for understanding Mount Tam. So if you're taking a profile of Mount Tam and you're starting at Stinson, and you're going to march straight up the mountain from Stinson Beach into Corte Madera, or to Marin General, right? And you're just going to go straight. You've got Venus Ridge, the north side, and you've got the ridge of Panoramic Highway on the south side. And if you take a look at the elevation of different spots along this transect, right, where you have Stinson at the beginning, right? This is distance from Stinson Beach. You got Rock Springs up here at around 2,000 feet, West Peak and East Peak, and then you got a pretty steep drop, on the east side. Venus Ridge starts kind of around 1,500 feet, kind of towards the south, and it slowly gets lower and lower as you go. And Panoramic Ridge right here is just around 1,000 feet. And if you take a look at that 93% area of fog, that's this band between these two lines. Below the mountaintop. So again, we've got this important feature of the topography on Mount Tam, and if you keep looking at satellite images, you see this pretty often. I'm going to step away for 1 second, really quick, because I'm losing my voice. Just give me a sec here. Be right back. Thanks. All right. So another important aspect of an environmental variable that affects the plants and where they're found is salt. So we've got a ton of aerosols that come off of the ocean. We've got species that are specially adapted to, right? So a lot of species that are you really won't find like just a few meters away from the edge of the bluff. And so of course that adds a whole other level of diversity to our landscape, Mount Tam. Yeah, so besides those parameters, right, there's other things that affect the vegetation. So we have a concept called succession, right, where the environment's just changing with time. And we've got fire, we've got logging, grazing, and unfortunately we have sudden oak death, right? So there's a lot of other big factors and variables to consider that affect the vegetation of any one place, but these are all pertinent to Mount Tam because we've got a history of logging. There's parts of the mountain, not a lot, that have a history of grazing, and of course, any area in California has a fire aspect to it, pretty much in the California Floristic Province, at this elevation. So let's take a look at some of those variables. In regards to fire, the fire regime is kind of like the overall characteristic of fire on the landscape. An important aspect of that is fire frequency. How often do fires happen? There's some other characteristics as well that go into fire regime. Take a look at Mount Tam. This is an incomplete fire map, but showing the known fire history in the 1900s. We had one really big out here that covered a good portion of Mount Tam, and then a lot of small fires. But we're not seeing areas that have burned more than once, at least based off of the map data. Just kind of some of the little sprinkly fires that overlap this old large fire, where you'd have an area that's has some recent fire frequency. The water district has some additional maps of fires that have occurred, and those are really interesting to take a look at and see kind of where spots where you've had multiple fires. And interestingly, there was a study done in Muir Woods in 1985 with Joe McBride, who was at Cal, looking at fire history in some redwood trees, and they determined that there was a pre-settlement interval of 22 to 27 years based on that study in the areas of Muir Woods where they analyzed tree rings, right? So that's a pretty frequent fire return interval. It's much different than what we see on the landscape in these days. So this is a really important topic, and has a lot of people interested and working to understand what the effect is on the vegetation. How do we manage this and create safety for our communities and also promote diversity? So it's a really, really interesting topic, and you can go out on the mountain and kind of make some connections with fire history. So, given all of those abiotic and biotic variables and processes, I kind of have like some zones that I consider important for Mount Tam that I reference in the field guide to kind of make sense of the species and kind of where you can find them. So one is this coastal strip. It's this that has that influence of aerosols, salt spray, and you get coastal bluff scrub, you get coastal prairies here, you get northern coastal scrub and coastal sage scrub. This is a pretty distinct zone that has unique species that you can't really find outside of this area. Then you've got the coastal scrub hills. These are like your Baccharis, Pilularis dominated coastal scrub communities intermixed with grasslands and other vegetation types, and the canyons and certain aspects of the hillsides. You've got a maritime chaparral and bishop pine kind of zone, where you've got Arctostaphylos sensitiva, and this is associated with some harsh different soils here that you find the bishop pine, the maritime chaparral growing in. You've got some areas where we have active grazing and historical grazing, right? And then you've got like a lot of wet forests that really get really get inundated with fog, or they just they're kind of your first line of defense, right? Orographically and in relation to fog. And I think that includes some areas of old growth forests, right? Muir Woods, it's low, it's that fog cover. It's in that valley, but it does get a lot of fog cover, which it benefits from. And then these old growth forests, you get species that you can almost are excluded to these areas. You can find them elsewhere, but it's very hard to, right? So these are some important areas that have unique species. There's another little zone of maritime chaparral, just above Muir Woods in that canyon. And then you've got this area called, or what I call the mountaintop, which we talked about earlier, that seems to be out of the influence of fog and has that mild weather, right? So a lot of the species up at the mountaintop you can find in the interior. There's not a lot that is unique here, but climatically, like from a microclimate perspective, it's pretty different. And if it's kind of its own zone, and there's serpentines up there as well. Some of the serpentine assemblages are a little bit different than what you find in the interior. You've got some cold air drainage and cooler forests on the north-facing slopes of Mount Tam, which seem to have their own kind of assemblages. Then you've got this like large area of interior serpentine mosaics, right, where you've got a really broad mix of vegetation types: grasslands, shrublands, forests, sargent cypress forests, and a big mix like what we were looking at earlier with the vegetation types on the landscape and those mosaics. Lastly, we've got these interior dry mosaics and the east side mosaics, which just is a way of saying that there's a lot of variability in the vegetation types that can be found there, depending on soil type and aspect to topography, and they do have properties that are pretty different. Like your California bay laurel forests in the interior are going to be very different than some of the bay laurel forests that you find on the more wet side. And again, if you go back to the vegetation map, you can kind of see aspects of this reflected in the fine scale vegetation map. Not fully, but there's some parallels. Like these little orange pieces are the chaparral, that Arctocephalus sensitiva, maritime chaparral that I was talking about. All right, so floristically, in California, we've got about 6,500 species. Marin flora, our source of truth for Marin, it's 520 square miles of land. California is 155, so we're talking about less than 1% of California, and we've got about 25% of the state's plant species here. So pretty amazing amount of plant diversity for such a small area. Super awesome place to do botany. It's great. And another part of the reason why we have so much diversity is, besides all those factors that we covered previously, is that we're kind of in a zone where a lot of these geographic subdivisions are coming together. So we've got components from the North Coast, we've got components from the South Coast, we've got our maritime, our northern maritime, floristic subdivision. We've got our Central Coast floristic subdivision. Here's a little close up, right? So you can see there's a lot of floristic subdivisions that folks who put the Jepson manual together, identify as kind of all in very close proximity to Marin. And so we benefit from getting, a little sampling from, I think, all of these, which adds to the diversity that we find here beyond, our soil diversity, our soil type diversity, and our topographic diversity, and our fog influence and the sea spray, right? And all these awesome, cool aspects of Mount Tam that make it what it is. And I won't go into the weeds here because I think I'm going to run out of time. But just taking a look at the Earth, and its history, there, speciation has been going on for, since the beginning, right? And if we're just starting at the Cretaceous Tertiary boundary when, dinosaurs went extinct, like California was pretty much in the sea. And I don't think we'll be able to go through all of these, but over time, like we had this major subduction event, which is why we have those serpentine soils and that Franciscan shale, and we had the Sierra Nevadas, building and then eroding and building again. We've our climate hasn't always been Mediterranean, right? So for a while we had warm waters off the coast. By the time we get to the, just before the ice ages start, which is the Pleistocene, we at about 3 million years, our Mediterranean-like climate develops. And there's a really cool book. It's kind of on the older side called Origins and Relationships of the California Flora by Raven and Axelrod, right? That's a really cool book that kind of explains this. If I had another life, I think that would be, the next project to work on is try to, with all the new knowledge we have, is just to try to summarize like how California diversity came to be, through time. That's really big on this Arcto-Tertiary influence of, northern latitude species mixed with like a Madrian element, which was kind of more southerly, and how those two elements kind of took off, once our Mediterranean climate got established, and the Dafic speciation that we have because of our serpentine soils is really cool. Right, and so present day, San Andreas is still in motion. The coast ranges are still rising. The coast ranges aren't Mount Tam. The parent material on Mount Tam is really, really old, right? But the elevation of the mountain isn't that old. So our coast ranges are still uplifting, right? As you get that compression from the San Andreas Fault. And so as we've seen, we know that there's a lot of diversity on Mount Tam. It's something that's been studied and documented for a very long time. Like here's just an example of a paper from 1965 looking at our regional hotspots of endemism. So these are species that are found nowhere else, right? So Mount Tam shows up there. And over the years, people have taken a look at endemic plant diversity and tried to figure out what parts of California have high. And Marin County, always stands out. Here's a great paper that Bruce at Cal did, looking at total native richness. They also have endemic richness in this paper, if folks want to check it out. That's super great, showing, again, the Bay Area is just this hotspot of native plant richness. And, depending on the methods used, like different studies have come up with somewhat different results, but over and over again, Marin just always kind of stands out as a biodiversity hotspot within a biodiversity hotspot. All right, so in terms of threats to this biodiversity, the classic ones are habitat destruction, fragmentation, right? Splitting habitats up, and the edge effects, the weeds that can come in, and other influences from outside the vegetation, invasive species, and global change. In terms of invasive species, the big shout out to all the agencies in Marin, state parks, Water District, Park Service, Marin County Parks, Golden Gate National Parks Conservancy, and others, right? They do an amazing job managing invasive species. This is just, we're so fortunate for all the effort that goes in here, because it really makes Mount Tam spectacular. It would be a lot of parts of Mount Tam, I think, would be a complete disaster zone if it wasn't for all the work these agencies put in. So it's a never-ending battle, of course, and there's a lot to do. But big shout out to the agencies for their work there. In terms of climate change, a lot of people, wonder what's going to happen with climate change and how that's going to affect, the landscape and the species that grow and wherever they live. There's been a lot of work done just with modeling, trying to understand the climate of an area and what its like counterpart will be, right? So one such study, predicts that in 60 years, San Francisco is going to be like where I grew up, right? And that's pretty different. So there's still a lot of uncertainty about what degree of climate change is going to happen in the future and what that means to our natural landscapes like Mount Tam. Another great study that came out quite a while ago, but it was like one of the first ones. It was super cool. Just showed how endemic plant species richness is going to change based on different models and based on the ability of plants to actually move, right? And I think one of the coolest things about this study is that like the immediate coast really in multiple scenarios really stands out as being very important for maintaining species richness in California. So just, I think, goes to show you that like it's even more important than ever to protect these lands out here on the coast, because they're going to really become refugia for a lot of our diversity. So yeah, some of the problems for plants with climate change is that it's going to be too fast. There's going to be natural impediments that won't allow certain species to migrate. There's going to be a lot of human impediments, right? No more like natural connectivity that's universal. And we've changed a lot of ecosystem processes. We've talked about fire earlier, and we've talked about some other aspects that can influence the species' ability to find the right conditions for success. And yeah, I just talked about this point about Marin being I think a really important area for the future. All right, so next up are the habitats. This part of the field guide describes all the habitats that you can find in Mount Tam. It stays at a pretty high level, so I'll just kind of run through some of these really quick, and then I think we'll go to questions, because we're gonna because I've eaten up a lot of the time, so apologize for that. But yeah, redwood forests are a big one, and the redwood forests in the valley are a lot different than the redwood forests you find up on the slopes. We've got Douglas fir forests on Mount Tam. This is our largest spatial extent vegetation type for forests, maybe for all of the vegetation types too. But Douglas fir forest is the main forest type that you find in Mount Tam. We also have hardwood forests, so we've got a lot of bay laurel forests. We've got very wet bay forests with tons of moss on the stems and tons of sword fern and other music species in those wet forests that I showed a map of. On the interior, you can find a lot of pretty different type of bay laurel forest, right? And oftentimes you also find these kind of more restricted to drainages where there's a little bit higher soil moisture. And you get other mixes of species in our bay laurel forests like big leaf maple and other kind of riparian species, since baby
Robert, I think you froze. Can you hear me? Robert, you're muted. I muted you to try to get you back. You need to unmute. You froze.
Thanks. Is that
There,
good?
yeah, there you go. You're back.
Am I still sharing my screen? Ooh, I lost your audio.
No, you're not sharing the screen anymore.
Okay. Okay, thanks. All right, we've got madrone-dominated forests, hardwood forests, we've got Oregon forests, we've got coastline oak woodlands, right? Where so oak woodlands have that open canopy. There's not that connectivity. We've got mixed hardwood forests and mixed woodlands as well. Just a lot of vegetation type diversity. Riparian forests like this red alder forest type. And then we've got riparian-like communities that are on the edges of some of the reservoirs that integrate with.
We still don't have your screen. Sorry.
Oh, thanks for letting me know. Okay, I got out of the slide and then I'm gonna hit presentation mode again. Is that better?
No, I don't think it's being shared.
Okay. Says I'm okay. Sorry about that.
There you go.
Okay. Yeah, so I was just showing some of the other forest types, madrone, Oregon oak woodlands, this coastline oak woodland, red alder, riparian forests, that are those linear features along the creeks on the coastal slopes. You get like riparian forests along some of the edges of our reservoirs. We get Sargent cypress forests. And that's, a sampling of some of the forest types that you can find on Mount Tam. And those are described in the book and some of the common species that you can find in those different types of vegetation types. Then we get into the shrublands. So chaparral is like the big one in terms of shrublands. We've got a lot of Eastwood manzanita dominated and chamise dominated chaparral. You can find it above Muir Woods. It tends to stay above like the fog zone, right? So we saw how the fog kind of doesn't just go up to the top of the mountain. It 93% of the time in that zone. And so once you get above that zone, you start, the more drier chaparral. After a fire, this was a fire up on up near Eldridge. Really interesting. This one got a pulse of bracken fern afterwards, which isn't too typical of what you think of for post-fire chaparral vegetation. So we've got more relatively mesic chaparral communities. I think technically it's all maritime chaparral based on like Mike Vassey's kind of definition based on his dissertation, from what I understand. So yeah, we get a little bit different dynamics after fires in chaparral, although that's not super well understood here because we haven't had a lot of fires. And then another thing that kind of is along the same lines, we get forests that start to convert chaparral. And so you'll see this a lot throughout Mount Tam. You'll be on a hike and you'll see like dead skeletons of manzanita. It's pretty common. So what happens is with a lack of fire, the vegetation goes through succession and gets replaced. The shrubs get replaced. So that's something that you'll notice when you're into chaparral. We get serpentine chaparral, and it can be closed canopy, it can be open canopy, it can be really diverse, it can be less diverse. It really depends, I think, on the soil type, how rocky it is, the degree of serpentinous. You get, more of a classic chaparral Mount Tam with the Marctostaphylos sensitiva. We get a different shrubland called coastal sage scrub, co-dominated by sagebrush. And we get more of your northern coastal scrub, which is, Baccharis with rhamnus and blackberry. After fire, this was the near fire. After fires, you see coastal scrub resprout. You see Lupinus arboreus come in. You see the blackberry can kind of go crazy, right? So all these different vegetation types just are unique little universes in themselves with their own, their own pool of species in the seed bank or adaptations of the species there that are going to respond differently to disturbances. It's just incredibly fascinating, and you can spend years just studying any one of these. We've got coastal bluff scrub on bluffs, which have a different assemblage of species. We've got a little bit of assemblage of coastal dunes at so just kind of like the beginnings, but nothing like Point Reyes, which has super mature coastal dune scrub. And then we get into the grasslands. The most prevalent grassland is our exotic annual dominated grasslands. But don't be fooled by the name. There's still a ton of native diversity in these grasslands, especially on Mount Tam. So these are the grasslands that have that classic golden like carpet of grass in the summertime. Also, our grasslands can type convert, so they can go through succession, and we see this very common on Mount Tam, where a lot of our more mesic grasslands, like Grizz-dominated grasslands, convert to coyote bush and Doug fir forests over time. But we also have some really great coastal prairies. This is a Idaho fescue-dominated coastal prairie. You'll find these in that coastal strip zone that was on that map earlier. And then we get native perennial grasslands with a good mix of native annuals. This is like an Elymus and Stipapulchra grassland, non-serpentine. So we've got really great non-serpentine native perennial grasslands. Got amazing serpentine perennial grasslands. These are one of my favorite like vegetation types on the mountain because there's so many cool species. Here's a beautiful Elymus squirreltail, mixed with wildflowers and other native grasses. I mean, we just have the most spectacular grasslands. I can't believe them. How lucky we are. You get native annual dominated serpentine grasslands too, like Calicadenia. Sometimes you get lithosiphon. Great. And that takes us through the grasslands, and then we've got wetlands like freshwater wetlands, like up in Potrero Meadow. We've got wetlands on the edges of the reservoirs that are highly native dominated. And then we've got some non-native-ish wetlands, on some of the reservoirs too, because of the management of these reservoirs may not, be ideal. Those native assemblages, or they're newer reservoirs, and there was just a lot more invasive species or non-native species that were at the time these were created at, right? But some of our reservoirs have like amazing native wetland rings around the shores, and others don't. I don't know exactly why, what causes that or not. That's an interesting thing to think about. And then we got rock outcrops. We've got non-serpentine rock outcrops, where you get tons of Dahlia cymosa, you get Cachelias, right? And you get other like rock specialist species. You get rock outcrops in the forests, they're covered with like sedum radiatum or mosses. And you've got serpentine rock outcrops, and we've talked about serpentine. All right, so that gets us through kind of the habitats and what's covered there in the book. Then we get into the species. The species are organized by the main taxonomic groups. In the book, we've got 1 lycophyte covered, 25 ferns, 7 gymnosperms, 3 magnolids. So you probably are following me with these first 3. The lycophyte is a selaginella, or a resurrection plant. Ferns, people know what those are. Gymnosperms are like conifers, and magnolids are an interesting group. There's 3 species. We've got let's see, ginger, bay laurel, and Dutchman's pipe that are part of the magnolid group. The majority of the book covers dicots, right, which is like the most diverse group of plants in California. And then second is monocots, which are some amazing like lilies and beautiful wildflowers and grasses and sedges, right? And so the book tries to include images of scanned plants so that you can kind of get good comparisons, although the vast majority are just still photos. But where possible, we tried to put those in. And here's some sample pages. So yeah, when there's tricky differences that people need to pay attention to, like the leaf margin to tell between white alder and red alder, we try to put in an extra photo to illustrate those points. Although, because of publishing costs and other factors, like we weren't able to go crazy. But I think people will appreciate those kinds of details. But in general, we have a description of every species that's covered that includes the scientific name, the common name, when it can be flowered, when it can be found flower, what kind of habitat it's associated with, and any notes or other important items to help people understand the plant or help to identify it. So the vast majority of the field guide is lists and sections of species like these sample pages. There's also some illustrations to help people understand the terminology that's used. Although this looks maybe overwhelming, I really tried to limit the use of botanical terminology, right? But we've got drew all these line drawings for the book, so those are available and hopefully helpful to people. And then I think this is one of the last. Yeah, this is the last slide. So I'm really sorry I've just gone for too long. Apologies. We just reviewed this slide deck, and I don't want to leave you with a different impression. Like in the slide deck, I went through and took
Robert, I think you froze again. I'm afraid we lost Robert. He'll be back in, hopefully. While we're waiting, we did a poll for the annual meeting for the election of officers and directors. And what I'm just going to run that again for any of you who are members. Oop. Oh. Well, that's interesting. The poll has disappeared, so I guess I won't be able to do that. I don't know why that happened, but in any case, let me just, while we're waiting for him to come back in, hopefully, tell you about next month's program. In January 8th, the speaker will be Miranda Mellon on the genus Detrichia, stinkwort, member of the Asteraceae family. That's a noxious weed in California, and she's a graduate researcher at the Invasive Plant Laboratory in UC Santa Cruz. So I think we're going to be talking about the plant science of invasive plants, which is certainly an important topic given how much problem and how much money is being spent on eliminating native plants. And hopefully she will provide us some helpful information about their control. I'm not seeing Robert, and he's not in the...
Hey, can you hear me?
Yes. Okay. You're back. Great.
Yeah, I'm sorry. I don't know what happened. Do you want me to finish up, or have you guys had enough?
Let's finish up. Anybody that has to leave can leave, but I'm sticking around to hear it.
Yeah, I know it's just part. So thanks for sticking around, everybody who's still here. Let's put this. I was just about done. Okay. Okay, so hopefully you can hear me and you can see the screen. I don't know where I left off. Did you see the glossary?
Yes.
Okay. Yeah, so this was actually the last slide. Yeah, so what I covered in this talk is pretty different than what the book covers, right? The slide deck that I put together for tonight really spent a lot of time on natural history and habitats, because to me, this is, those topics, were really interesting and helpful to understand Mount Tam and the diversity you can find. versus going through all the species and just going page by page through the different species accounts. But over here, the book is mostly a field guide with species accounts, and the natural history and the habitat section is pretty light, right, compared to what I talked about in today's call. So that was the last point to make, and I'm done. So again, apologies for going late, and thanks for everyone who was able to stick around.
Well, I think while we have you, I would not want to miss even given the hour, the opportunity for anybody to ask questions. And
Yeah.
so if you have a question, you can put it in the chat, or you can use the reaction button to raise your hand and ask it in person. And Robert, would you stop sharing so
Yeah.
so we can see participants a little better?
Yeah, just hit pause sharing.
Yeah, great.
Okay.
Any questions?
I have a question. Hello, Robert. Nice to see you.
Hey, Clint.
What is your favorite plant?
Oh man, that's always a tough one, right? I think one of my favorite plants in the whole state is Salvia carduacea, thistle sage. That one always like kind of gets me every time I see it. It's just this like, it looks just like a thistle, but it's a salvia. It's like the coolest thing, right? On Mount Tam, I really like Western burning bush, which you find in Muir Woods. That's a neat plant. I like the flower. That's what I had at the last slide on the thing. That one's one of my favorites. And gosh, I don't know. There's just tons. So
I have Western burning bush in my garden.
oh, nice.
It's a lovely little plant.
Yeah.
Nona Dennis has a question.
Yeah. Quick question. It was a wonderful presentation. Fascinating. I've been looking at Mount Tam for 60 years from my windows. I've been on a lot, but I did do a double take when you showed in one of your earlier slides pointing out the various vegetation groupings, and you showed bishop pine on the east side. On the east side of the fault. And I wondered how it was as a wet forest, I believe, and along the Bolinas Ridge, but on the east side of the fault. And I just wondered how that computes with our understanding of bishop pine, which is sort of limited to the west side.
Yeah, right. So up near Inverness, you've probably got the most extensive bishop pine forests in the county.
Right.
And those are on the west side of the fault. And then you also have some smaller stands on the east side. So one area is along Bolinas Ridge.
Yeah.
I think it's associated with I think it's some granitic soils there. And then you also have some bishop pine along San Geronimo Ridge too. So these aren't as extensive as what you find around Inverness, but there is some bishop pine on Mount Tam in those two locales, at least.
Yeah, right. Fascinating. Yeah, I had no idea. Others probably knew this, but I didn't know that. So thanks very much.
Yeah. If you want to learn more about the San Geronimo Ridge bishop pine, in the field guide, there's a reference to a study that Constance Miller did maybe 20 years ago that talks about those bishop pines. It was an article in Madronio, and you can take a look.
I see. So that would be north of the Bolinas Fairfax Road.
Yes.
Okay. Near the Olima Valley, in that area. Well, whatever. Don't worry about it. But
yeah, like San Geronimo Valley.
I'm thinking of Olima Valley. I'm not certain exactly. Oh yeah, I know San Geronimo Valley, certainly.
Yeah. So ridge kind of like parallels through Francis Drake, just to the south.
Right.
And there's some bishop pine up there too.
Yeah. Okay. Thank you.
Yeah.
Julie Bongers has a question. Julie, you can unmute.
Yeah, I unmuted, sorry. I'm not sure this is exactly a question, but I think you might, when I was first in near Beach and Green Gulch in the late 70s, they were still grazing, I think all the way into maybe the beginning of the 90s on that sort of land around Green Gulch Farm. But I was told when I first moved there, which was probably 78, that Frank Valley, where Muir Woods is, had not been grazed for 70 years. So I just thought that might be interesting to you. And one of the things that also I've observed that I think you might find interesting is that the Douglas fir that's coming up all around Green Gulch Valley there was one tree, I think, or maybe two when I first moved there in 78. So that's kind of interesting because you can really see there's a lot of here and there in the chaparral now. A lot of fairly sizable ones, actually. Not huge, just really noticeable, and there's lots of them. So I just find that interesting.
Yeah, that's a good observation. I've seen some Douglas fir on the hills around Green Gulch. Another tree species that I see a lot around there is Monterey pine too.
Coming up in the chaparral?
Yeah,
Monterey pine was not, well, first of all, there's what Green Gulch planted, but Monterey pine was not the first thing coming up in the chaparral. It was Douglas fir.
Yeah, there's definitely Douglas fir around there that's come up. Good observation. We're seeing Douglas fir coming up in a lot of new places throughout the landscape.
And also, I remember when I first moved there, someone told me, some botanist, that you could, and he was really talking about the coast, really quite close along the coast. He said everything that grows along the coast all the way to the Oregon border can be found on Mount Tam, or once could be found on Mount Tam. I think there's some azaleas that are no longer there and some other things. So I thought you might find that interesting.
Yeah, I mean that might be an exaggeration, right? Because the diversity is pretty extensive. Once you start going further north, you get a lot of like Saxifragaceae species, like right along the immediate coast, for example, that you don't get on Mount Tam. So I think he was exaggerating a little bit.
Well, yes, I'm sure, because this person was a good tall tailer, but he also, I should have been more specific. He wasn't talking about the immediate, like the where the sedums and all grow along the, he wasn't talking about dunes and coastal cliffs. He was really talking about hillsides. It was a rather specific conversation. It's just, it was a long time ago. So I'm sort of dredging it up out of my memory.
Nice.
And he definitely wasn't talking about the full Klamath Range or some Kennedy Alps or something like that.
Ben has a question. Ben, you can unmute.
Yeah, Robert, so Julie mentioned Douglas firs, and I'm curious. My grandpa, years ago, my mom always talked about the fact that my grandpa started a tree farm, a Christmas tree farm, up on the slopes up there somewhere. With the Douglas fir, is it local, or is it something that's just been there? But have you seen anything that would resemble a tree farm up there? My mom's talked about it before.
Okay. Yeah, like above Mill Valley, there's been some pines that have been planted, and the Marin Flora book does a pretty good job describing kind of where some of the exotic pines in the county have been planted in different spots on Mount Tam. So it's possible the tree farm, was associated with some of those pines. If the tree farm was a Douglas fir plantation, Douglas fir is native to Mount Tam. But I don't recollect seeing like a pine tree plantation on the slopes of Mount Tam. I don't know if anyone else on the call has observed that.
Hey,
I'm
Any,
not- Yeah, go
sorry.
ahead. No, go ahead.
any other questions? If not, Robert, I really want to thank you for providing that wonderful context to your field guide, which I'm sure we're all going to use and thumb like you have thumbed the Marin flora, as you described. It's going to probably be our, new Bible, new plant Bible. So many thanks for what you've done and really the years of labor you put into this. These things don't happen instantly, and that timeline of yours really expresses, I'm sure, the thousands of hours that went into this, and so many thanks. And I just wanted to remind people that if they want to get that 30% discount on the book, go to the Marin CNPS website, which is the link is in the chat, and in the cart, put in full caps Tamalpais. That's the discount code, which will be good until December 18th. So again, thank you, and we look forward to seeing you January 8th at our next program. So.
Thanks for the opportunity. Really appreciate you guys.
Good night.
Good night.